Today we're stepping into the fascinating and mind-bending world of parallel universes, a concept that has gripped the imaginations of scientists, philosophers, and storytellers alike. The idea that our universe might not be the only one, that there could be an infinite number of realities running alongside our own, is as thrilling as it is bewildering. Parallel universes aren't just the stuff of science fiction anymore. They're part of serious scientific inquiry, grounded in theories from physics, quantum mechanics, and cosmology. So why is the idea of parallel universes so captivating? Perhaps it's because it offers us a perspective that's different from anything we've been conditioned to believe. For centuries, humans have seen the universe as singular, a single continuum of space and time where we exist, live, and die. But the concept of parallel universes challenges this notion entirely, suggesting that everything we know, every event, every person, and even every decision may exist in different forms across multiple realms. Imagine a world where you made different choices, where your life took completely different paths. Each choice could give rise to a separate reality, a distinct parallel universe, layered invisibly alongside our own. One of the reasons parallel universes have moved from philosophical pondering to serious scientific discussions is the progression of modern physics. Breakthroughs in quantum mechanics, the field that examines the smallest particles in our universe, hint that multiple outcomes might coexist simultaneously. The rules governing quantum particles are strange, defying what we consider possible or logical. Particles can exist in multiple states at once or interact with each other across distances, almost as if they're in touch with particles in other realities. When scientists first observed these quantum behaviors, it led to new ideas, including the mind-bending concept that if particles could have parallel existences, maybe entire worlds could too. The study of parallel universes is also intertwined with the expansion of the cosmos itself. Many scientists believe our universe is still expanding, pushing the boundaries of space farther and farther away. Some even propose that beyond these boundaries might lie entire universes, vast realms that we simply can't perceive. And according to these theories, there could be an infinite number of such universes, each with its own unique laws of physics, its own galaxies, and perhaps even its own versions of Earth. This idea is called the multiverse theory, where our universe is but one bubble in an unfathomably large cosmic foam. Beyond science, there's a philosophical allure to parallel universes that's impossible to ignore. What does it mean to be you in a universe where countless versions of you might exist? Could one of these parallel versions of you have achieved dreams you didn't, or experienced outcomes you could only imagine? In some ways, the concept of parallel universes forces us to confront questions about our own identity and purpose. If every choice leads to a different outcome in some alternate universe, what does that mean for the significance of our decisions? Are they uniquely our own, or simply one of countless possibilities? Parallel universe theories also stir up a unique kind of existential curiosity. We humans have a deep-seated urge to understand where we fit in the grand scheme of things. Discovering that we're part of a multiverse, that our universe is just one of an infinite many, can be as humbling as it is inspiring. It's a reminder of both the power and the mystery of existence. It's not only scientists who are inspired by these ideas. Artists, authors, and filmmakers have used them as a backdrop to explore everything from human choices to the mysteries of time and fate. Think of classic films and books where characters encounter alternate versions of their own lives, each path representing a different reality. These stories tap into a universal curiosity about the what-ifs that haunt us all. In recent decades, as science has progressed, our imaginations have expanded as well. Concepts that once seemed too wild or abstract are now being explored through advanced simulations, algorithms, and mathematical models. We're no longer just asking what if, but instead how. Could there really be other realms, perhaps imperceptible to us, where things unfolded differently? The journey into the concept of parallel universes is not just a quest for scientific truth, but a quest for meaning. If there are endless versions of us and countless alternate realities, what does that imply about our choices, our relationships, and our dreams? Does it add weight to the life we lead, or does it diminish the uniqueness of our existence? Maybe in the end, exploring parallel universes is less about finding answers and more about expanding our perspective. It's a journey that pushes the boundaries of what we know and challenges us to see beyond our everyday reality. As we move forward, we'll dive deeper into the different theories and perspectives that attempt to explain the possibility of parallel universes, from quantum mechanics and cosmology to philosophical questions and ethical considerations. The mystery of parallel universes is one of the most captivating frontiers in science, and the more we explore it, the more we realize how much there is left to uncover. The concept of multiple worlds goes back thousands of years and is deeply rooted in ancient mythologies and belief systems. Ancient civilizations like the Greeks, Hindus, and Norse imagined realms beyond our own, suggesting that the universe was not singular. In Hinduism, the idea of many worlds manifests in cosmology, with the belief in countless cycles of creation and destruction occurring in the universe's kalpas, or cosmic ages. The concept implies that there are realms where different events unfold, each with its unique timeline and inhabitants, making it one of the earliest examples of parallel universe thinking. Greek philosophers, too, contemplated the idea of worlds beyond our perception. The atomist philosophers, Leucippus and Democritus, speculated that atoms in infinite combinations could form endless worlds, some resembling our own, others drastically different. This speculation laid the groundwork for the idea that our universe could be one among many, each following its path and reality. Later, philosophers like Epicurus further expanded this notion, suggesting that infinite worlds exist throughout space. These ancient beliefs might seem mystical, yet they are surprisingly close to the modern idea of the multiverse. Philosophers continued to expand upon the notion of multiple universes, using it to explore human nature, reality, and ethics. Plato's concept of the world of forms introduced the idea of a realm beyond physical reality, where perfect versions of every object and concept exist. Though not strictly parallel universes, the forms introduce the idea that reality is more complex and layered than what we perceive with our senses. This notion opened a philosophical pathway for considering realities beyond our experience. In the medieval period, Islamic philosophers and scholars like Al-Farabi and Avicenna explored metaphysical questions about the nature of existence. They posited that multiple worlds could exist within a hierarchical structure of the cosmos, with each layer offering a different degree of divine truth. This philosophical framework sought to reconcile spiritual and scientific understanding, pushing the boundaries of human thought about the nature of the universe. Even René Descartes, the philosopher known for his statement, "I think, therefore I am," proposed a thought experiment where reality could be an elaborate illusion created by an all-powerful evil demon. This concept, though not a multiverse theory, introduced skepticism about the reliability of human perception, inspiring future thinkers to question the singularity of reality. Descartes' approach set the stage for later discussions on the simulation theory and the possibility of alternate worlds. As science began to develop during the Enlightenment, the concept of parallel universes found a place within scientific theories. Isaac Newton's work on gravity and motion reinforced the idea of a predictable, mechanistic universe. However, even Newton's theories couldn't fully explain every aspect of the cosmos, and gaps in understanding left room for alternative interpretations. Some thinkers speculated that universes with different initial conditions could lead to worlds vastly unlike our own. With the rise of scientific inquiry, scientists like William James, an American philosopher and psychologist, brought parallel universes back into discussion with his idea of a multiverse in the early 20th century. James used multiverse not to describe parallel realities in a literal sense, but to suggest a diversity of experiences, perspectives, and truths in human life. However, the term later evolved, especially with the advancements in quantum mechanics and cosmology, to refer to actual, physical universes coexisting with our own. Another scientific figure, Hugh Everett III, proposed the many worlds interpretation in the 1950s, which offered a revolutionary approach to understanding quantum mechanics. According to Everett's theory, every possible outcome of a quantum event leads to the creation of a new, separate universe. For example, if you flip a coin, both heads and tails result, each in a distinct universe. This bold idea was initially met with skepticism, but later became one of the cornerstones of modern parallel universe theories. Parallel universes have long captured the imaginations of writers, artists, and filmmakers, offering endless creative possibilities. From literature to cinema, the theme of alternate realities has been explored in countless ways. One of the earliest popular depictions of parallel universes is found in Lewis Carroll's Alice's Adventures in Wonderland, where Alice steps into a fantastical realm through a rabbit hole. Although not a literal parallel universe, Wonderland challenges our understanding of reality and echoes the idea of worlds hidden within our own. In the mid-20th century, science fiction began to explore parallel universes more directly. Writers like Philip K. Dick and Isaac Asimov used alternate realities to question the nature of identity, free will, and society. In Dick's The Man in the High Castle, for example, he imagines an alternate world where the Axis powers won World War II, creating a dystopian reality parallel to our own. This novel is an example of how parallel universes can be used to reflect and critique human behavior, history, and choices. Cinema also embraced the concept of parallel universes, particularly in films like The Matrix, Inception, and Interstellar. These movies used alternate realities and dream worlds as metaphors for human experience, consciousness, and the unknown. They remind us that while our reality seems concrete, the possibilities of alternate worlds challenge us to rethink what is real and what lies beyond our perception. In modern times, the exploration of parallel universes has moved from myth and philosophy into the realm of scientific inquiry. Today, the idea of parallel universes is supported by advanced theoretical models in physics, especially quantum mechanics and cosmology. Concepts like the multiverse and the many worlds interpretation provide a framework for understanding how parallel realities could be scientifically possible. Quantum mechanics, with its strange and counterintuitive rules, suggests that reality isn't as solid or singular as we might think. Particles can exist in multiple states simultaneously, which, according to some interpretations, could lead to entire universes branching out for each possible outcome. This strange quantum behavior has led some physicists to believe that our universe is part of an endless network of parallel realities, each following its unique path. In cosmology, the multiverse theory posits that our universe may be just one of an infinite number of universes, each expanding and evolving separately. This theory arises from observations of cosmic inflation and the vastness of space, which suggests that beyond the observable universe, there may be other universes with their own physical laws, matter, and dimensions. Each of these realms could represent a parallel universe, completely detached from ours, yet following similar or radically different rules of existence. These scientific advancements are still theoretical, yet they give credibility to ideas that were once dismissed as mere fantasy. As technology progresses, so too does our ability to explore these hypotheses. While we may not yet have direct evidence of parallel universes, the tools of modern science bring us closer to understanding whether we truly are alone in the cosmos, or if countless other realities are unfolding right alongside us. The journey from ancient mythology to advanced physics reflects our evolving understanding of the universe, bridging the mystical with the empirical. The idea of quantum mechanics began in the early 20th century, as scientists sought to understand the behavior of particles at incredibly small scales. At the time, classical physics explained motion, energy, and gravity accurately for objects we could see or measure. However, when researchers looked closer, down to atomic and subatomic particles, they found that the laws governing larger objects didn't apply in the same way. Classical physics couldn't predict how tiny particles behaved, and this discrepancy laid the groundwork for a new theory: quantum mechanics. Max Planck, Albert Einstein, Niels Bohr, and Werner Heisenberg were among the pioneers of quantum theory. Their work revealed that energy and matter exhibit wave-particle duality, meaning they behave both as waves and particles depending on how they are observed. This discovery challenged centuries of scientific understanding and reshaped the foundations of physics. The wave-particle duality, coupled with the uncertainty principle proposed by Heisenberg, suggested that observing a particle's position or velocity inevitably changes one or the other. In essence, quantum mechanics showed that reality itself seemed to shift based on observation. The notion of superposition further complicated the picture. Quantum particles could exist in multiple states at once, only choosing a particular state when measured or observed. This mind-bending reality led to the development of various interpretations of quantum mechanics, the most famous being the Copenhagen interpretation and the many-worlds interpretation. The Copenhagen interpretation suggests that particles remain in superposition until observed, while the many-worlds interpretation, pivotal to multiverse theory, proposes that each possible state of a particle exists in its own distinct universe. The idea of quantum superposition underlies the concept of multiple realities within quantum mechanics. According to this principle, particles don't have a single definite state, but rather exist in a range of potential states simultaneously. This phenomenon is perhaps best illustrated by the famous thought experiment, Schrödinger's cat, where a cat in a box is both alive and dead until someone observes it. This paradoxical situation highlights how quantum mechanics defies our common understanding of reality and time, hinting that multiple outcomes might coexist independently. The many-worlds interpretation, developed by physicist Hugh Everett in the 1950s, addresses this paradox by proposing that every possible outcome of a quantum event leads to a separate, parallel universe. Instead of choosing between outcomes, the universe splits into multiple realities, each containing a different outcome. In the Schrödinger's cat example, one universe contains a living cat, while another contains a dead cat. This theory implies an infinite number of universes, each branching off from every possible quantum interaction. This view aligns with the concept of a multiverse, where countless versions of reality exist side by side, separated by quantum events. The idea that every decision or event spawns a new universe challenges our understanding of causality and free will. If every possible action creates a new universe, then every possible version of each person also exists, experiencing each possible life path. This notion of parallel selves is captivating yet unsettling, raising questions about individuality, purpose, and the nature of identity. According to the many-worlds interpretation, we are all part of an intricate web of countless realities, each shaped by every conceivable outcome. Quantum mechanics further stretches our understanding of reality through the phenomenon of entanglement. When two particles become entangled, they remain connected no matter how far apart they move from each other. This connection is so profound that a change in one particle's state instantaneously affects the other, defying the limits of space and time. Einstein famously called this spooky action at a distance, as it seemed to violate the speed of light constraint in classical physics. Entanglement challenges our notions of locality and causality. In traditional physics, objects influence each other only within proximity, and causality flows in a straightforward manner. However, entanglement suggests that particles can communicate instantaneously across vast distances, hinting that the universe might be interconnected in ways we don't yet fully understand. The implications of entanglement are profound for multiverse theory, as they suggest that parallel universes may not be isolated entities, but could, in theory, be connected through entangled states. If particles in different universes are entangled, actions in one reality could influence or mirror outcomes in another. This interconnection challenges the idea of separateness and implies a more unified structure beneath the multiverse. While current experiments have yet to establish inter-universal entanglement, the concept provides a tantalizing glimpse into a potential network connecting countless realities, perhaps explaining phenomena that remain mysterious in quantum mechanics. Quantum decoherence plays a key role in understanding how quantum superposition interacts with the classical world we experience. In simple terms, decoherence describes how quantum states, which initially exist in superposition, collapse into a single measurable state when they interact with their environment. This process aligns with our everyday experience. Objects exist in one place at one time rather than in multiple states simultaneously, as superposition would imply. Decoherence doesn't necessarily mean that other possible states disappear, rather they become inaccessible or hidden from our perception. According to the many worlds interpretation, these alternate states still exist, but in separate parallel universes. Decoherence thus explains why we observe a single reality despite the existence of multiple potential outcomes. In a sense, decoherence serves as the mechanism by which universes split, with each new universe reflecting a different version of reality. This theory aligns with the idea that each observer experiences only one outcome of any given event. While quantum mechanics allows for all possibilities, decoherence means we perceive just one, with the others branching off unseen. If true, this mechanism is continually creating universes, shaping an ever-expanding multiverse where every possible version of reality unfolds separately, yet simultaneously. The result is a structure so vast and complex that it defies comprehension, encompassing every outcome and possibility. Quantum mechanics has proven accurate and reliable in countless experiments, yet the multiverse implications remain unproven. Theories like the many worlds interpretation are compelling, but direct evidence of parallel universes remains elusive due to the limitations of our current technology and understanding. However, recent advances in quantum computing, entanglement experiments, and particle physics are bringing us closer to potentially observing phenomena that might support the multiverse theory. Quantum computers operate by harnessing the principles of superposition and entanglement, enabling them to process information in fundamentally different ways from classical computers. The very functioning of these computers offers insights into the quantum world, suggesting that manipulating and observing quantum states may one day provide indirect evidence of other realities. Experiments involving the creation of entangled states and superposition states also continue to push the boundaries, exploring what might be possible in quantum mechanics. The Large Hadron Collider, LHC, and other particle accelerators allow scientists to study conditions that approach the Big Bang, potentially offering clues about the nature of reality. Some physicists speculate that particles detected in these experiments could display properties that hint at parallel universes or other dimensions. While these findings are far from definitive, they reflect our growing capacity to probe the mysteries of existence. Looking to the future, advancements in quantum technology may one day allow us to interact with or even observe other universes. Although still highly speculative, such breakthroughs could redefine our understanding of reality, confirming the existence of a vast multiverse. Until then, the quantum multiverse remains a fascinating yet largely theoretical field, prompting us to question the nature of our reality and our place within an incomprehensibly large cosmos. The exploration of quantum mechanics and the multiverse reshapes the boundaries of science, philosophy, and human imagination, leading us to an era where we might one day prove the existence of other universes that coexist with our own. The study of cosmology has ancient origins, as early civilizations sought to explain the universe's structure and scale. Early cosmologies centered around Earth as the universe's center, with celestial bodies revolving around it. This geocentric view, supported by Ptolemy and others, persisted until the heliocentric model emerged, thanks to Copernicus, Galileo, and Kepler. With Newton's laws, we gained a mathematical understanding of celestial movement, but the true scale of the universe remained mysterious. Modern cosmology began with Albert Einstein's general theory of relativity, which transformed our understanding of gravity and space-time. Instead of seeing gravity as a force, Einstein described it as a curvature in space-time caused by mass. His equations showed that the universe wasn't static but could expand or contract, a concept later confirmed by Edwin Hubble. Hubble's observation of galaxies moving away from each other implied an expanding universe, leading to the widely accepted Big Bang theory. However, the Big Bang doesn't explain what lies beyond our observable universe. Could the universe be infinite, extending beyond what we can observe? This question has led to the development of the infinite universe theory, which suggests that beyond the observable cosmos, there may be an endless expanse. This theory holds that the universe doesn't have an edge. Rather, it may continue forever, possibly with regions similar to our own and others vastly different. The observable universe is the portion of the cosmos we can detect with telescopes, limited by the speed of light and the age of the universe. Since light takes time to travel, we can only see as far as light has traveled since the Big Bang, around 13.8 billion years. This distance defines our observable horizon, creating a spherical view of the universe roughly 93 billion light-years in diameter. However, this boundary doesn't imply an edge, rather it marks the limit of our current observational capabilities. The observable universe contains billions of galaxies, each with billions of stars, yet it represents only a fraction of the entire cosmos. Cosmologists believe that beyond this observable region, the universe may continue indefinitely. While we cannot directly observe these distant regions, theories in cosmology suggest that the universe is either infinite or extremely vast, containing regions that lie beyond our reach. This concept has profound implications. If the universe is indeed infinite, then everything we know, the galaxies, stars, and even our existence, might be just one small part of an incomprehensibly vast reality. Some scientists propose that distant parts of the universe might contain regions identical to our own, a result of the finite ways matter can organize itself. In an infinite universe, every possible arrangement of matter might exist, leading to the mind-bending possibility of parallel versions of ourselves. Infinite universe theories arise from multiple branches of physics, particularly in inflationary cosmology and quantum mechanics. Inflationary theory, proposed by physicist Alan Guth, suggests that the early universe experienced an exponential expansion, or inflation, within fractions of a second after the Big Bang. This rapid expansion explains why the universe appears homogeneous on large scales and predicts a universe that could be infinite, or at least vastly larger than the observable portion. The notion of an infinite universe also intersects with quantum mechanics, especially through the many-worlds interpretation. This interpretation posits that every quantum event results in a branching of realities, leading to an infinite number of universes with every possible outcome. While the many-worlds interpretation focuses on separate realities created by quantum events, it aligns with the idea that infinite variations of existence could be possible, adding another layer to the concept of an endless cosmos. Cosmologists often debate whether the universe is closed, open, or flat, terms that describe the shape and fate of the cosmos. A closed universe would curve in on itself, potentially resulting in a finite cosmos. An open universe would expand forever, creating an infinite expanse. Observations of the cosmic microwave background radiation, leftover radiation from the Big Bang, suggest that the universe is flat on large scales, indicating that it may be infinite. However, our understanding is limited, and these measurements provide indirect insights rather than definitive answers. The concept of an infinite universe often leads to the idea of a multiverse, an ensemble of multiple universes, each potentially with its own physical laws and constants. While the multiverse is distinct from an infinite universe, the two ideas overlap in fascinating ways. Theories like eternal inflation suggest that the rapid expansion after the Big Bang could give rise to separate bubble universes, each forming its own distinct cosmos with unique properties. In this framework, our observable universe is one of countless bubbles within a larger multiverse. These bubbles may be entirely isolated, unable to interact with one another. Some may contain familiar physics, while others operate under radically different laws. In an infinite multiverse, every conceivable form of existence could unfold, with infinite variations of life and matter. The multiverse idea has gained traction due to both theoretical and observational insights. For instance, the fine-tuning of physical constants in our universe suggests that our cosmos is uniquely suited for life. However, if an infinite multiverse exists, each universe might have different constants, and our existence becomes one outcome among countless possibilities. This perspective raises philosophical questions about purpose and existence, as we are one of many possible outcomes in a vast, potentially infinite array of universes. The infinite universe theory challenges not only our scientific understanding, but also our philosophical and existential perspectives. If the universe is truly infinite, then every possible version of reality could exist, rendering our experience one of many. This idea raises questions about individuality, purpose, and free will. Are we unique or just one iteration of countless versions? An infinite universe also affects how we perceive time and space. In a finite universe, the concept of an end suggests a clear boundary, but in an infinite cosmos, there is no center or edge, and the concept of spatial limits becomes meaningless. This infinite nature complicates our understanding of origin and meaning, as traditional cosmological theories often rely on a universe with a beginning and a potential end. Additionally, the infinite universe theory has implications for the search for extraterrestrial life. In an infinite cosmos, life should theoretically exist elsewhere, potentially in infinite forms. Some regions might host civilizations similar to ours, while others could contain life forms beyond our imagination. The vastness of the universe may mean that intelligent civilizations are separated by distances so vast that interaction is unlikely, leading to the concept known as the cosmic isolation hypothesis. The theory also invites us to rethink our place in the cosmos. Humanity has long viewed Earth as a central location within the universe, but an infinite cosmos suggests that our existence is one small part of a much larger, boundless structure. This realization can be humbling, reminding us of the scale of the universe and the mystery that lies beyond our understanding. Time, in classical physics, is often viewed as a linear progression, a constant flow that moves from the past through the present and into the future. This perception aligns with our everyday experiences. We measure time in seconds, minutes, and hours, marking the rhythm of life with calendars and clocks. The classical understanding of time is largely rooted in the works of Isaac Newton, who described it as absolute and uniform. In his framework, time flows independently of the events occurring in the universe, serving as a backdrop against which all phenomena unfold. Newton's conception of time as an absolute entity laid the groundwork for much of classical physics. It allowed for the formulation of laws of motion that governed the behavior of objects in a predictable manner. However, this deterministic view of time began to shift with the advent of modern physics. In the early 20th century, Albert Einstein's theory of relativity revolutionized our understanding, revealing that time is not a constant, but is relative and intertwined with space in the fabric of space-time. In Einstein's view, time can dilate based on the observer's relative velocity and the strength of gravitational fields. This means that two observers, moving at different speeds or situated in varying gravitational conditions, can experience time differently. This relativistic perspective raises intriguing questions about the nature of time, particularly in relation to the concept of parallel realities and multiple universes. Quantum mechanics introduces further complexity to our understanding of time. At the quantum level, particles behave in ways that defy classical intuition. Instead of following deterministic paths, particles exist in states of probability, exhibiting behaviors that are fundamentally uncertain. The role of time in quantum mechanics is less about a steady progression and more about the relationships between events and their probabilities. In this framework, the concept of time becomes intertwined with the observer's measurement. When we observe a quantum event, we force the system into a particular state, collapsing the wave function that describes its probabilistic nature. This interaction between observation and reality raises profound implications for understanding time within the context of parallel realities. One interpretation of quantum mechanics, known as the many worlds interpretation, posits that every quantum event spawns multiple branches of reality, each representing a different outcome. In this model, time does not simply progress in a linear fashion. Instead, it unfolds in multiple directions, creating a vast array of parallel realities. Each decision, every particle interaction, leads to a branching of timelines, suggesting that time operates differently across these realities. In the context of parallel realities, time takes on a multifaceted role. If we consider the many worlds interpretation of quantum mechanics, every moment in time may result in the creation of a new universe. This means that in one reality, a decision is made that leads to a specific outcome, while in another, a different choice leads to an alternate outcome. The implications of this branching time model challenge our conventional understanding of linear time, suggesting that each decision creates a new timeline that exists concurrently with others. Each of these timelines operates independently, leading to divergent histories and futures. In this way, time becomes a dynamic and fluid construct within the landscape of parallel realities. Each reality unfolds according to its own temporal narrative, influenced by the decisions made within it. This raises the question of how these timelines interact, if at all. Are they entirely isolated, or is there a mechanism by which they might influence one another? The relationship between time and parallel realities also suggests a more profound interconnectedness. If all possible outcomes exist in parallel universes, then time may serve as a bridge between these realities. Concepts such as time travel or shifts in consciousness could be interpreted as ways to navigate through these diverse timelines. The exploration of time in parallel realities opens up a realm of philosophical inquiry about fate, choice, and the nature of existence itself. The exploration of time in parallel realities brings forth intriguing philosophical implications. If every choice creates a new timeline, what does this mean for concepts like free will and determinism? Traditional notions of free will are often predicated on the idea that individuals can make choices that shape their destinies. However, in a model where every decision spawns a new reality, the concept of free will becomes nuanced. While one may feel that they are making a unique choice, that choice results in countless alternative realities where different decisions were made. This multiplicity of outcomes leads to questions about the nature of identity. If there are infinite versions of oneself existing in parallel realities, which one is the true self? Are we defined by the choices we make, or are we merely one manifestation of a broader, interconnected consciousness that spans multiple realities? The existence of parallel timelines invites contemplation on the essence of individuality and the impact of our decisions. Moreover, the nature of time itself becomes a philosophical puzzle. In a universe where time is relative and influenced by observation, how do we reconcile our subjective experiences with the broader tapestry of parallel realities? The linear progression of time may feel intuitive in our daily lives, but the underlying reality of time could be far more complex, intertwining with the multiverse in ways we have yet to fully understand. As we delve deeper into the relationship between time and parallel realities, the concept of consciousness emerges as a crucial player. How does consciousness interact with time across different realities? Can consciousness traverse these timelines, or are we bound to experience time in a linear fashion? The exploration of consciousness within the framework of parallel realities raises profound questions about the nature of existence. Some theorists suggest that consciousness may not be confined to a single reality, but could extend across multiple timelines. This notion implies that our awareness might tap into parallel experiences, influencing our perceptions and choices in this reality. The idea of consciousness as a collective phenomenon aligns with various philosophical traditions that view consciousness as interconnected rather than isolated. Furthermore, the experience of time can vary significantly based on one's state of consciousness. States such as meditation or altered consciousness can distort our perception of time, leading to moments where time seems to expand or contract. In the context of parallel realities, these altered states could offer glimpses into other timelines, enabling individuals to experience moments from different realities. This perspective suggests that consciousness is not merely a byproduct of the brain, but a fundamental aspect of our engagement with time and reality. As we explore the role of time in parallel realities, we must also consider how it influences our experience of reality itself. The way we perceive time shapes our understanding of events, relationships, and our place in the universe. In a linear model, we view time as a sequence of moments, each leading to the next. However, in a multiverse scenario, time may be experienced as a series of interconnected events across multiple timelines. This interconnectedness raises the possibility of shared experiences among individuals across parallel realities. Could two people, existing in different timelines, share a moment of profound connection, only to diverge in their subsequent paths? Such experiences might foster a sense of empathy and understanding that transcends the boundaries of individual realities. This notion invites us to rethink our relationships and interactions with others, acknowledging the complex web of connections that may exist beyond our immediate perception. Moreover, the experience of time is deeply tied to memory. Our memories shape our understanding of who we are, influencing our decisions and relationships. In a universe where every decision creates a new timeline, memories could become a bridge between parallel realities. They might serve as reminders of choices made in other lives, fostering a sense of continuity and identity across diverse experiences. This interplay between time, memory, and identity opens up new avenues for understanding the human experience in a multiverse context. The exploration of time in parallel realities has practical implications as well. If time is not a fixed entity, but rather a fluid construct influenced by choices and observations, how might this understanding impact our approach to decision-making and personal growth? Recognizing the interconnectedness of our choices and their potential to create divergent realities can encourage a more mindful approach to life. Individuals may begin to view their decisions not merely as isolated events, but as part of a broader tapestry of experiences that influence not only their lives, but also the lives of others across parallel realities. This awareness can foster a sense of responsibility and intentionality in how we navigate our lives. By considering the potential impact of our choices on multiple timelines, we may become more compassionate and empathetic toward others, recognizing that we are all interconnected in the vast expanse of existence. Furthermore, understanding the nature of time in parallel realities can inspire creativity and innovation. Artists, writers, and thinkers can draw upon the notion of multiple timelines to explore new narratives and ideas. The concept of parallel realities invites us to think outside the confines of linear storytelling, offering a canvas for imaginative exploration that transcends traditional boundaries. By embracing the complexity of time and existence, we can tap into new realms of creativity and expression. As we explore the concept of parallel realities, we inevitably encounter a myriad of philosophical questions that challenge our understanding of existence, consciousness, and the nature of reality itself. The implications of living in a multiverse extend far beyond mere scientific curiosity. They touch on the very fabric of our moral and ethical frameworks. If multiple realities exist, where every decision creates divergent timelines, what does that mean for concepts such as free will, identity, and responsibility? This chapter will delve into these profound philosophical inquiries, examining how the existence of parallel realities reshapes our understanding of ourselves and the universe around us. One of the most pressing questions arising from the theory of parallel realities is the nature of reality itself. In a multiverse framework, the definition of what is real becomes increasingly complex. Each reality can be seen as a unique manifestation of existence, where different outcomes and histories unfold simultaneously. This leads to the question, what is the significance of a reality if countless others exist with different possibilities? Philosophers have long grappled with the nature of existence, and the concept of parallel realities amplifies these discussions. Existentialists, for instance, might argue that the awareness of multiple realities highlights the absurdity of life, suggesting that meaning is not inherent but constructed through individual experiences. This perspective aligns with the idea that each choice we make contributes to a unique narrative, emphasizing the importance of personal agency in crafting one's existence. Conversely, this multiplicity of realities may also challenge the notion of significance itself. If every decision spawns countless alternatives, does any single choice hold meaning? The existential weight of our actions can become diluted in a sea of potential outcomes, leading to feelings of nihilism. Yet, it can also inspire a deeper appreciation for the moments we experience, as each one contributes to the rich tapestry of existence across various realities. The interplay between free will and determinism becomes particularly complex in the context of parallel realities. Traditional views on free will suggest that individuals have the capacity to make choices independent of external influences. However, if each decision leads to the creation of new timelines, the nature of free will may be reframed. In the multiverse theory, every choice you make branches off into a new reality, creating alternate versions of yourself. This presents a paradox. If every possible decision exists in some reality, how free are we in our current choices? Are we simply players in a cosmic game where every outcome is predetermined by the existence of these alternate realities? This philosophical quandary invites exploration into the nature of responsibility. If multiple versions of ourselves exist, each making different choices, to what extent can we hold ourselves accountable for our actions? The ethical implications of this question are profound. They challenge the foundations of our legal and moral systems, which are predicated on the assumption of individual responsibility. Philosophers such as compatibilists argue that free will can coexist with determinism, suggesting that individuals can be free in their choices, even within a framework where outcomes are predetermined. In the context of parallel realities, this could imply that while every decision branches off into another timeline, the agency we experience in making choices remains meaningful. The existence of parallel realities also prompts us to reconsider the concept of identity. If countless versions of ourselves exist across different timelines, what defines our true identity? Are we merely the sum of our choices? Or is there something more fundamental that ties us together across these realities? Philosophical discussions on identity often revolve around the notion of continuity, our memories, experiences, and self-awareness. However, in a multiverse where alternate versions of ourselves may lead radically different lives, this continuity becomes fractured. Each version of you may have distinct memories, experiences, and even personalities based on the choices made in their respective realities. This raises the question, what does it mean to be you if there are infinite iterations of your existence? Are we defined solely by our actions, or is there an underlying essence that connects us across these realities? Some philosophers propose that identity is not static but dynamic, shaped by our experiences and relationships in both this reality and potential others. Furthermore, the exploration of identity in parallel realities encourages us to consider the implications for empathy and understanding. If we recognize that others may be living out different versions of their lives in alternate realities, it could foster a greater sense of compassion. This awareness invites us to appreciate the complexity of the human experience, acknowledging that each individual navigates a unique narrative shaped by their choices. The ethical implications of living in a multiverse are profound and multifaceted. In a reality where every choice creates a new timeline, the weight of our decisions carries additional significance. While we may experience the freedom to choose, the knowledge that each decision gives rise to a multitude of outcomes can create a moral burden. Consider the ethical dilemmas we face in our daily lives. Each choice we make impacts not only our lives, but also the lives of those around us. In a multiverse, the consequences of our actions ripple across multiple realities, influencing alternate versions of ourselves and others. This interconnectedness invites us to consider the broader implications of our decisions and fosters a sense of responsibility toward our choices. Moreover, the notion of ethical responsibility extends to the idea of potential futures. If we can imagine a world shaped by our actions, we must grapple with the ethical implications of those imagined realities. What kind of future do we want to create, and how do our choices contribute to that vision? In the face of uncertainty, ethical frameworks must evolve to account for the complexity of living in a multiverse. Utilitarianism, for instance, could take on a new dimension as it emphasizes the greatest good for the greatest number. In a multiverse context, this framework may lead us to consider not just the immediate consequences of our actions, but their implications across alternate realities. As we navigate the philosophical landscape of parallel realities, the role of consciousness becomes paramount. Our awareness of multiple outcomes influences our decision-making processes, shaping the ethical frameworks we employ. The capacity for self-reflection and critical thinking enables us to evaluate the potential consequences of our choices, both in this reality and others. Consciousness serves as a bridge between our understanding of the multiverse and our ethical responsibilities. It allows us to ponder the ramifications of our actions, fostering a sense of empathy and moral consideration. In recognizing that our choices may have far-reaching effects, we cultivate a greater awareness of our interconnectedness with others. This exploration of consciousness also raises questions about the nature of ethical responsibility. If our awareness extends across multiple realities, to what extent can we be held accountable for the choices made by alternate versions of ourselves? This inquiry invites us to consider the complexities of moral judgment and the nuances of personal responsibility in a multiverse context. The philosophical and ethical implications of parallel realities extend beyond individual considerations. They resonate on a societal level. If we accept the existence of multiple timelines, we must grapple with the impact on our social structures, institutions, and cultural norms. In a society that acknowledges the multiverse, traditional notions of success, achievement, and failure may shift dramatically. If every outcome exists in parallel realities, the pressures of competition and comparison may become less significant. Instead of measuring ourselves against others, we may come to appreciate the diversity of experiences and paths available to individuals. Moreover, the recognition of parallel realities may foster a more inclusive and compassionate society. If we understand that every person exists in a web of interconnected choices, we may cultivate empathy for the struggles and triumphs of others. This perspective encourages us to value diversity, as each individual embodies a unique narrative shaped by their decisions and experiences. The ethical implications of parallel realities also have the potential to reshape our political and social frameworks. Policies and decisions made by leaders could be influenced by an awareness of their broader consequences, leading to more thoughtful and responsible governance. As we consider the complexities of living in a multiverse, we may become more attuned to the interconnectedness of our global community. As we draw our exploration of the multiverse to a close, we find ourselves reflecting on the profound implications this theory holds for our understanding of existence. The journey through quantum mechanics, cosmology, and philosophical considerations has illuminated the vast landscape of possibilities that parallel realities present. Each chapter has unraveled a layer of complexity, inviting us to reconsider the nature of our reality, our choices, and the interconnectedness of our lives. The multiverse theory challenges the very foundation of how we perceive reality. In a universe where countless timelines exist, each marked by different decisions and outcomes, we are confronted with the realization that our lives are part of a much grander tapestry. This awareness can be both exhilarating and overwhelming. On one hand, it empowers us to embrace the infinite possibilities that lie ahead. On the other, it may evoke a sense of uncertainty as we grapple with the implications of our choices. One of the most striking insights from our exploration is the impact of parallel realities on our understanding of identity. If we exist in multiple forms across different timelines, what does it mean to be you? The concept of identity becomes fluid, shaped by experiences, choices, and the myriad of outcomes that unfold in each reality. This perspective encourages us to embrace the complexity of our identities, recognizing that we are not defined solely by our actions, but also by the potentialities that exist within us. Moreover, the discussion of free will within the multiverse framework raises essential questions about accountability and responsibility. If every decision branches into a new reality, how do we navigate the ethical implications of our choices? This inquiry compels us to cultivate a deeper awareness of our actions, understanding that they resonate beyond our immediate experience. In a multiverse, our choices are not merely personal. They ripple through the fabric of existence, influencing alternate versions of ourselves and others. The philosophical implications extend to our social structures and cultural norms. As we recognize the interconnectedness of our choices across parallel realities, we are invited to foster empathy and compassion. A society that acknowledges the multiverse may encourage individuals to appreciate the diversity of experiences, fostering a sense of community that transcends the boundaries of individual timelines. This understanding can inspire a collective approach to addressing global challenges, emphasizing collaboration and unity in the face of uncertainty. Ultimately, our exploration of the multiverse invites us to embrace the complexity of existence. We are reminded that life is not a linear journey, but a series of interconnected paths, each shaped by our decisions and experiences. The awareness of parallel realities encourages us to approach life with curiosity and openness, recognizing that each moment is an opportunity to shape our narrative. As we conclude this journey through the multiverse, we invite you, our viewers, to reflect on the ideas we've discussed. How does the concept of parallel realities resonate with your understanding of life? What choices do you find yourself contemplating in light of this new perspective? We encourage you to engage with these questions and explore the possibilities that lie within your own life. If you've enjoyed this video and found the exploration of parallel realities thought-provoking, please consider subscribing to our channel, The Storyteller. Your support helps us continue to bring you content that inspires curiosity and fosters meaningful discussions about the nature of existence. Additionally, we invite you to like this video and check out our other content, where we delve into similar topics that challenge our perceptions and broaden our understanding of the universe. Each view, like, and subscription contributes to a community dedicated to exploring the mysteries of life and existence. Thank you for joining us on this journey through the multiverse. We look forward to continuing this exploration together, uncovering new insights and expanding our horizons. Until next time, embrace the complexity of your existence and the infinite possibilities that await you in every choice you make.